Hello, everybody, and welcome. So excited to have everybody here today for our location intelligence with maps and geoanalytics in Microsoft Fabric. My name is Philippa Burgess, and I am here with our fantastic team. And I'm going to let everybody introduce themselves. I'm going to start with, just kind of a brief introduction of myself. I am Philippa Burgess, and I have just come out of grad school where I studied geospatial uh, and security, and have been a Microsoft student ambassador and also an Esri ambassador. And so when I saw that they were integrating, I just was so excited about sharing this and feeling like this was a great opportunity for me to be an evangelist for something that I was very passionate about, both the Esri side of it and the Microsoft side of it. And if you're not familiar with Esri, you will be by the end of our session. So really excited to share that with all of you. And then I'm going to go ahead and introduce um, our moderators. And everybody knows I'm still kind of learning everybody's names correctly, so I'm going to let you guys introduce yourself. So I turn it over to, I'm just going to start with Thumb. Actually, Lee's back. Okay. Obviously, I'm going to have you. Lee, can you start by introducing yourself? And then we'll go down the.
Sure. So, hi everyone. I'm Nikita and I'm joining from India. I'm a recent graduate and this is my first time moderating a data day session. Um, I've been participating in data days and learning the community, and it's been really fun there. I'm excited to support today's session and learn along with all of you. So, welcome and thanks for being here.
Fantastic. Yeah, so excited to have everybody. Okay, Lee.
Hi everyone, I'm Lisana Lamufula. You can call me Lee. I'll be your lead moderator today. I'm also a Microsoft Learn Student Ambassador. I'm studying information systems at Northwest University in South Africa, and I'll be your lead moderator today. Thank you.
Fantastic. All right, and our third mod. And you have to give me the correct pronunciation of your name.
Yeah, yes. My name is Krishnakant. Um, I'm connecting from Bangalore, India, and I've been participating in the day-to-day sessions, and I'm also recently I got a super user, and looking forward for the today's session and being moderating. Thank you.
Fantastic. All right, great. So excited to let's move this along here. Okay, so we've got our introductions. And also, I would say, like, my stage is always open. I've had two speakers say, hey, I'd like to come join you. So I always say welcome. But I think there was, so I was like, if you're here, you're here. If you're not, you're not. This is my session. I definitely own this topic. I'm so excited about talking today. And with our great mods, we're going to have a great session. I'd love to know where everybody is joining us from. We've got a great live turnout. We have almost 300 people signed up for this event, which is amazing. And we've had 700 sign up over our series that we're going to be doing. So let's just talk about the context of why we're here. This is all part of Data Days. And Data Days is 60 days of data and AI, kind of running from mid-June to early August. It's a great opportunity to get certified. So they will have certifications for DB 600, 700, 800. This is a qualifying event. So if they say, have you been to I think you're supposed to be part of two events, and there's just a form you'll fill out. We'll drop everything in the links for that. But just know that this is part of a greater Data Days event for Fabric, and that there's over 100 sessions. There's study groups. There's the Data Viz World Champs. So lots of opportunities for you to get hands-on practice and build your portfolio. And then there's also there's the Fabric user group panel, and there's also lots of different user groups. I lead a user group, which is this is part of what we're here, is the location intelligence and security user group. So what we'll cover today, we're talking about why location intelligence belongs in Fabric. We'll get to know Esri and their ArcGIS Pro platform, which is kind of ArcGIS maps for Microsoft Fabric. We'll get into GeoAnalytics in Microsoft Fabric, and then we'll give you a demo and basically give you a link. You can actually run this demo yourself. And then where do we go next? So we'll bring all that to you. And yeah, it's and so I want to talk about this sort of paradigm shift from attribute to signal. And so I'll give you a little bit of background in my studies. I started graduate school just kind of with the idea I was ready for a professional reset, and started with an online program in urban planning, thinking that was kind of an easy entry point for me to just kind of figure out where I wanted to go next. I didn't really have a sense of it, and I always thought urban planning was a bit of pacing. It wasn't the cake. It's very broad, and there's so many interesting economics and politics and demographics and just everything about our cities and our spaces and how the history and development and issues of equity and environment. And it was fascinating. I loved it. But I felt like so many of the people in my cohort were either already architects, real estate developers, had law degrees, business degrees. And I came from a content marketing, entertainment media background. And I was like, I don't really know where I go with this. And so I felt that the thing that then revealed itself to me is we had one class, which was kind of a very light coding class. And I just fell in love with it. It was clear I was miles ahead of everybody else in the cohort. I love the data. Absolutely, when we got to the data visualization piece of it, I was like, yep, this is my jam. This is exactly what I want to do. And having some mentors who were professionals in GIS, I said, is this something I can learn on my own, or should I do an academic program? And they said, if you have an opportunity to do an academic program, do that. But I also want to say that having come out the other side of an academic program, there's pieces of it that you can do yourself. And what I love about the integration now we have with Microsoft and Esri is that this is actually designed so you don't need a master's degree. I think that's where Esri realized they were sort of falling behind, is that you did need such technical training to even get started on their platform. And by bringing it to Microsoft and putting it inside Excel and Power BI and Fabric, it's designed for everybody to start being able to make maps and start thinking spatially without having that master's degree. So anyways, I went on to get a second master's in, started with a certificate in GIS, and then went on to a second master's in human security and geospatial intelligence. And then because I was doing a lot with government, realized that if I'm going to work with data, I'd like to know how to keep that data secure. And that led me to a third and final master's in cybersecurity. So now I'm done. But my favorite thing is teaching in the public square and bringing this information forth to everybody so that it's accessible, it's understandable, and I just like the tools are there for us to use. What's also nice about what we're going to talk about today is there's parts of it that require a enterprise license, and there's parts of it you can do actually on your own in a notebook that's not even part of Fabric, where you can still make maps. I have scripts that you can just do it in Colab, and at the end you'll have a data map. So there is wonderful ways which you can. And I do see a question. Yes, this is like all live streamed, so it's all there for sort of instant replay. And then we always kind of do like post-event resources, and I try to do some blogs and some places where you can get quick links and other things to sort of make it easy as well. But we love having you here. We love having you live. If you're able to join us live, it's fantastic. But if you can't or can't stay for the whole thing, we get it, and it's here for you. So with that, I just want to say that coming up through data science and data, it is very siloed. So people who learn spatial don't actually get into the Power BI and like really deep dive into the Excel, or even are introduced to the world of Fabric. Whereas a lot of people who come up in data science don't really learn about spatial sciences. And so and same thing, like I even feel like security, there's amazing whole ecosystem of the cybersecurity people. And I feel like they're so siloed. And I'm like, we all need security. We all need to be thinking. And when you get into data, you've got row level security, you've got governance. And so that's this whole series that we're going to be doing is going to be covering data and cybersecurity and location and sort of AI and sort of that mix of all of it. So anyways, the idea is you can now take a cell that's on that's in your table, and you can really give it context. What are we doing here? What do we see? Where's this actually located? And so then this is why I'm so excited about bringing Esri directly into Fabric. So we're going to talk about the different tools that exist. So you've got ArcGIS, which again is Esri is a privately held company, and this is sort of their proprietary software, and their main platform is ArcGIS Pro. And so now they have ArcGIS Analytics for Microsoft Fabric, ArcGIS Maps for Microsoft Fabric, and ArcGIS for Power BI. There's even location tools inside of Excel as well. So the idea is, like, I just want to invite and encourage everybody to sort of start thinking spatially as a data scientist. So it's great to see that there's tools. And again, these tools range from high code to no code. And in the middle, you've got the low code version. So you've got, so your GeoAnalytics is going to be high code. ArcGIS and Maps is going to be low code, no code. And same thing, like ArcGIS for Power BI is no code. So you've got sort of the spectrum. And same thing with like the licensing. There's going to be things that you can do with your general sort of Fabric license, and whatever capacity you've added to your Fabric tenant. There will also be things that are sort of enterprise grade. And we'll talk about that today. So for example, the GeoAnalytics, which is more of the enterprise grade, is in general availability. And the Maps is now in public preview, so it's free. So it's a great time to sort of jump in and take a look at that. So why location belongs in Fabric is that spatial patterns reveal what tables and charts cannot. Just like kind of looking at just maps, just like starting to look at maps. I want to say I led a session that was for urban planners, and it was about being a map reader, a map leader, and then a map maker. And I want you to think the same way as well, because being a map maker can take some time, and there is a learning curve. And I want to basically say that the very first thing you want to be thinking about is being a map reader, meaning start to think spatially, start to look at maps, start to understand what is the map trying to tell us, what can we learn from a map. So just visually, you've got a city and sort of something sort of lit up here, kind of like, and you're seeing, and then on the right side you've got California, and you've got the 5, and obviously there's places where that are in red indicates like there's a problem here, and then yellow is like, okay, maybe that's kind of moving a bit more. We don't know what the data is reflecting, but the idea is it's telling us a story. It's trying to tell us something. And so looking at different maps, this one, I'll tell you exactly what the story is. This one is basically looking at a wind pattern for insurance risk, saying sort of for this hurricane, who is going to be impacted and at what severity of impact based on wind speed coming through this particular corridor of southern Georgia and northern Florida. And so there's all sorts of ways. And then you can also, with maps, you're looking at, there's a graphic representation of the data, and then there's the map representation of the data. And then there's points. So you've got points on a map that tell us where various locations are. So it could be where you have a retail location, or where you have a utility, or anything that represents, it could be buildings that were built before a certain year or built after a certain year. It could, they can represent anything. But again, when you can visually see it, there's so much more context that we can get from our data. Now, this data originally lives in tables or in shape files, which are unique to kind of GIS. What I love about this and what we're talking about today is that nobody here needs to be a GIS, which is either stands for Geographic Information Systems or Geographic Information Sciences. You do not need to be a GIS professional. That's what I love about this. You can actually just be the data scientist that you are, or the data analyst, and start to incorporate spatial thinking and spatial maps into your work and into your communications, and tell better stories. You can also track data over movement and time. So you get the terms spatial temporal data. So here, perhaps this is like ship routes. And you can see sort of different things as they move and change over a period of time. So there's so many cool things that we can do with maps. And Esri has been around, say, for about 50 years, more than 50 years. It was founded by Jack Dangerman and his wife Laura in the 1960s. and it is one of the largest proprietary software privately held companies, and they are the software we use to make maps. It's incredible software, and they also have what they call a living atlas, which is an amazing resource, and it's incredible, and it's now integrated with Microsoft. And so these are, and what the living atlas is gold standard data, so that is that you can use and access. But data exists everywhere, and there are already location data, whether it's the name of a country, the name of a state, the name of a province, the name of its coordinate system. There's data hiding for location data hiding in the data that you already use every day. But with Esri, you now are able to get absolute sort of enterprise level mapping capabilities. And you can also get basic mapping capabilities. Like I said, you can run a script without enabling any of the GeoAnalytics or the ArcGIS map tools, whether you're using your notebook in Fabric or you're using a Colab notebook or a Jupyter notebook, or you're in wherever you are and you're running a notebook, you can create a map very simply. There's other tools like Geoda, and so there's fee and free ways to start making your maps. But yeah, Esri is what we're talking about. This is the software company that's, like I said, integrating with Microsoft and enabling all of this spatial analytics, again, natively into Fabric. So you can clean and transform the data, you can analyze critical events, you can define spatial relationships, and you can identify optimal locations. So there's just so much to do. We'll kind of cover that again today. So what changes? Like, why is this so exciting? It's because previously we had GIS systems were separate from business intelligence. Your data warehouse was siloed. You had separate security models. You had separate governance layers, and you had multiple teams and handoffs and delays. Now, integrated into Microsoft Fabric, the One Lake is one spatial data storage. The ArcGIS natively in Fabric notebooks. You get one security model for row level security, column level security. There's now one governance layer with Purview, and so your data, your AI, your maps can all be in one platform. And so location intelligence is no longer a GIS project, it's now a Fabric workload. And that brings us to, sort of the, so traditional BI, so the role of location, a label is used for filtering or grouping. Now with spatial, it's continuous context for discovery and enrichment. With analysis type, so relational and aggregated, some group by join, you now have concepts of proximity, routing, and spatial joins at scale. So visual outputs, flat charts and static shape maps are now layered, can be interactive topological maps. Enrichment is internal data only, manual data appends, and here you have living atlas and open data layers in one lake. And then, and as we're kind of here to talk about today, it's the Fabric native tools now. So now this is all, again, now in general availability or in public preview. So the ArcGIS Map for Maps in public preview. Now again, this is the no code, low code sort of exploratory visual analysis for business intelligence analysts, smart mapping and dynamic heat maps directly in the workspace. And then GeoAnalytics for Fabric is the Spark native, heavy code, scalable, spatial, ETL. So you've got 180 plus functions for data engineers running on distributed compute. And so we're just a real quick recap as we we'll look at these separately in a moment, but just kind of before we do, kind of understanding what is the difference between the maps and the GeoAnalytics. So the ArcGIS Maps for Fabric, it's going to be a mapping workload in the Fabric Workload Hub. Who uses it? Analysts, data professionals, business users. How to use it? No code UI, connect, enrich, publish. Core capability, interactive maps and living atlas overlays. Output, Fabric web map artifact, which is shareable. And the status, again, is public preview, so it's free during this preview. And the ArcGIS GeoAnalytics for Fabric is going to be the Spark native Python spatial library. It's for data engineers and data scientists. You can write Python and PyScripts. It's PySpark in a notebook. You've got 180 spatial functions at Spark scale. It's enriched data frame and delta tables, and now it's generally available, so you will need a license for it. But again, when you're just getting started with spatial thinking and spatial maps, there's a lot you can do just kind of running your own notebook. Now, the nice thing here is you don't need a master's degree. It's nice of you, and you don't need to sort of be a GIS professional. What is great here is that you can sort of be exactly where you are and get some spatial concepts that you can bring into your work as a BI professional, as a data scientist, data analyst. So that's what I want to run through now, is grounding you in some key spatial concepts before we get into a bit more detail about the maps and the geoanalytics. And then I'll give you a demo, and I'm just going to run you through where the data lives, what that demo is going to look like, and then you can run that on your own. And then we'll kind of talk about what's next and where you take it from here. So key spatial concepts. So basically I'm bringing you a master's degree in 30 minutes. So when you think about maps, one of the things I want you to start thinking about is points, lines, and polygons. So you've got discrete locations. So what is a point? It's a discrete, it's a customer, it's a sensor, it's a store. So each is a row with a longitude and latitude. You've got lines. These are paths and connectors, routes, pipelines, ordered sequences of coordinate pairs. And then polygons are areas and boundaries, zip codes, sales territories, an outline of country, so polygons. So they're closed shapes enclosed in an area. And those are referred to as vector data. So anything that's a point, line, on polygon is a vector. So it's used for business data, CRM locations, boundaries. So most of your BI work is going to happen here in points, lines, and polygons. And also I want to just sort of say, when you do a heat map, you are actually working with points. It's just a different visualization of it, but still vector imaging. Raster is different. If you may or may not have heard, I know before I started my graduate studies, I had not, of terms like remote sensing, or there's kind of IoT, Internet of Things. And that's all, or satellite imagery, drone imagery, any of that kind of analysis is based on rasters. So rasters is a continuous surface of grids of pixels. So yeah, you can use it for satellite imagery, elevation, climate. So it's climate heat maps are going to be more of a raster. So think of it as like a photo that lays over something. And then you're doing an analysis at a pixel level. So they're a bit of they're a bit different in terms of the analysis and how you use them. So pretty much as you're starting with this, you're going to be focused on the raster and just understand that. Sorry, you will be focused on vector and just know that raster exists. To that end, I will say that I have tried to use some raster data in Fabric, and I love Fabric. But I found it as kind of limited. It's not there yet. It can't fully store or unpack or specifically unzip that data. And I work with a lot of raster data. I do a lot of satellite imagery analysis in my work. But I also do a lot of Fabric. I love Fabric. So spatio-temporal analysis, we started to show that those sort of lines moving before. So you can also look at data and how it has changed over time. So you can look at location patterns, and you can add this like sort of spatial clusters. You can track how hotspots evolve or spread or dissipate. You can look at crime waves or sales trends or a virus spread. And so data definitely changes over time, and we can now visualize that. And then you can do buffer analysis. So beyond straight lines, the difference between customers within a 5-minute radius and customers within a 5-mile drive time are actually different because you've got rivers, highways, a lack of bridges kind of changes that real world proximity. I know there's a restaurant we particularly like, and oftentimes if we get a particular uh, doctor's appointment, it's like, oh, we should go there, but it's like, no, but it's across the highway. It literally, you think it's across the street, but it like actually takes 30 minutes to get there. I have decided, I'm like, you know what? I'd rather go to that restaurant like another time, but not try to go like after the doctor's, because it takes 30 minutes to get there. But even though it is literally just you can see it practically, but you have to kind of go around the highway. So the idea that 5 miles on a straight line is not always going to be sort of 5 miles of drive time. Again, on a road network can be quite different. So thinking in terms of those barriers and accessibilities, uh, and then analyzing movement. So you can track reconstruction. So converting raw telemetry into continuous travel corridors. So there's sort of that, you can have messy GPS pings of a cell phone. And then now you can sort of see like, well, where did they go? What did that actually look like when you kind of put it on a map in a particular order? What was the order of those? So you can reconstruct the tracks, group timestamp points by edge DIDs, connecting them sequentially into continuous line strings. You've got polygon buffering. Applying a variable distance buffer generates polygon convex hulls around paths. Snap tracks align noisy GPS telemetry to OpenStreetMap road networks using node connectivity and flow directions. And then you can calculate motion statistics, derives speed, bearing, acceleration, and dwell times automatically. I do want to acknowledge something like OpenStreetMap. Again, if you're not familiar with that one, that is what they call VIG, which is volunteered VGI, volunteered geographic information. So it's crowdsourced from the public, and so OpenStreetMaps is one of the largest ones. So anybody can be a contributor to it and update it based on things that you see or experience, and that way it's kind of gotten from everybody. What do our communities look like? What's there or not there? I had actually done a project where I was looking at OpenStreetMaps in the United States and in India and China. It's actually technically illegal in China, although it is it's frowned upon. It's not particularly welcome, but it exists. China's actually pretty well mapped on OpenStreetMaps. Just never ever map or report on a military facility or anything that's sort of considered top secret, because that is a very severely punishable crime. I also learned, for example, between the United States and India, that a playground in the United States is where children go that has swings and seesaws and kind of it's designed for small children. Whereas in India, which we can speak to, I'm going to bring our mods here in a second to come chime in. It is where you play cricket. So that's another reason we get into, and we'll continue in our series, themes like ontology. How do you define things? And are we defining and talking about the same thing? And so that's another aspect of it. So I'm going to check in with our mods. How you all doing? Lee, is this new information for you? Are you seeing this for the first time? Do you have questions?
None so far.
All right. Is this? Are you finding this helpful in your own data journey?
It is helpful because you get to see
Good.
new things like, oh, okay, so this I can use.
Fantastic. Good.
Thanks.
Krishna?
Yeah, it's very interesting topic, and for me, it's a new where I'm learning things from the session. So yeah.
Fantastic. And Nikita? All right, if you want to pop in at any point, feel free. Nikita, I'm just checking in with you.
Checking it.
All right, let us move on to our next topic. We've got a lot to cover. Okay, so these are just high-level concepts. Again, you probably, again, if you're out the gate, these are not the first things you're going to see, but there are words and concepts, and this is where sort of the difference in the boundaries, and this is what I want to, I guess the takeaway from this one is understanding there is a boundary between business intelligence and GIS, and there's a point where there's a lot you can do as you incorporate maps, and then there'll be levels of things that you may want to engage your GIS colleagues to help, or there's parts of the project that you just may pass along to them that are just definitely outside of scope. But there's concepts, for example, like a heat map will show raw density where things are, and then there's hotspots. The GEDIS or GI show statistical significance. Is this cluster actually meaningful or just random noise? So regional averages can hide local variation. So the spatial autocorrelation reality, things that are close together behave more similarly than things that are far apart. So that's why regional averages can hide local variations. There's like Tobler's first rule of geography, that things that are closer together are more related than things that are far apart. And so that's kind of just kind of keeping to thinking about sort of just some of these ideas of when you look at location data to actually ask questions, like actually does this make sense? And so sort of inside the engine of the hotspot analysis, the statistical significance, and so just basically embracing statistics, I think we do as data science professionals, but it really applies to anything that's location based. So the Find Hotspots tools will evaluate a local neighbor's average against the global data set to find non-random clusterings, things that are actually significant, things that will help you tell a story that makes sense. And then you get to sort of do spatial joins. The where based is the VLOOKUP. So connecting data by location, not by ID. So you can join customer points to demographic polygons simply because the point falls within the ingest raw parquet data. So you're looking at sort of that ST underscore within or ST underscore intersects. So you can clean out out of bounds anomalies. So kind of get rid of like kind of the null. You execute ST within with a demographic polygon and write enriched data tables to one link. So this is kind of how you are joining your data, and you're joining it based on the location. The big thing that sets like anything that's I can call GIS or spatial data apart is the fact that we live not on a sphere, we live on a bumpy ellipsoid, and that requires measurement and obviously topography. We have peaks and valleys and oceans and all of the things that make our world unique in its shape. So we want to think in terms of how do we take a roundish globe and project it on a flat surface. The reality is when you do that, you're always going to have distortion. And you get to choose your distortion. So are you distorting the area, meaning things look larger? We see that on the, in a lot of the maps that we use. We distort the, or the distance is distorted. And so you just kind of have to figure out which one you choose. So every flat map you've ever seen is a choice. It is a choice that is made by the cartographer, because you cannot, you're taking a globe and you're just putting it on a flat map. Things that you'll learn, other things is kind of the, so there's a projection. So when you put information from that globe into that flat map, the question is, how are you projecting it? So one of the things that you'll sort of hear or come across is WGS 84. It's kind of a geographic projection, and it's sort of standard for web visualizations, and it's measured in degrees. So Web Mercator and State Plane is a projected, and that's flattened for accurate meter-based distance area calculations. So things when you do your projections, they're going to be either referred to as geographic projections or projected, and then the scale. Scale was one of those things that took me a minute to learn, just the idea that it's an inverse relationship. So when you think about a small scale and you think about a city, it's actually the opposite, because if the city is a large scale because you're getting to look at it really closely, and the globe is a small scale because you don't get much detail. So if you're looking to understand, just when you think about something that's like a small scale, you think little detail. When you think large scale, you think of it of great detail. And then so that silent killer is if you have a misprojection. So if your the geographic or the projected that we just talked about is wrong, it's not so much right or wrong. The data is what the data is. But when you have a mismatch and you're trying to connect data that comes in different projections and different coordinate systems, that's one of the things you have to do is you have to start to normalize that data and make sure all of the data is converted into the right projection system. So that's one of the very first things you want to look at when you're looking at spatial data is what is the projection and are all of your projections aligned? And if they're not, that's the first thing you want to do is doing that transform to align any mismatched layers. Otherwise, things will not locate where you expect them to locate. And you will find your data in the middle of the ocean, which is where it does not belong. So those are things just to think about. Okay, so there's just like a translation. These are things you already do, things you already know, the way you already work as a BI and data professional or a student. However, if you're in that sort of silo, we're now trying to expand that silo, but to see that there's a lot of it's the same. We just use different words. So it's a lot of it's going to be just getting the vocabulary. So in GIS, the vocabulary is a point or a polygon, and your equivalent as in BI and data is going to be row and grouping dimension. A spatial join is basically SQL join on location. Coordinate systems, it's time zones for data. Hotspot detection is outlier detection. So there's a lot of equivalencies. It's just kind of understanding that you're just having to translate a bit and expand the conversation out just a bit outside of sort of where we're all kind of traditionally trained. And then contextual enrichment with biospatial joins, your internal data tells you what, and the spatial context tells you why. And with the ArcGIS Living Atlas, which is an amazing thing to explore, there's so much data there, and then they've done so many different projects kind of visualizing it. You can look at environmental data, climate data, elevation, hazard zones, demographic data, population density, age distribution, income, lifestyle, foot traffic, retail activity, mobility. And so you can enrich one lake data using st underscore contains or st underscore intersects. So data engineers can spatially join massive business data sets with living atlas polygons directly in Spark, adding external context to internal analytics. And things to think about, just kind of visual styles for selecting the right map. So there's going to be things that are high density or low density in terms of the amount of features. And then a feature is the first word, one of the first words I learned in GIS, feature. It is the thing that you are analyzing or visualizing. You can have many features. They all lay on top of each other. But so what is your feature, and do you have a lot of them, and do they overlap, or are they just sort of individual? And so an example here in the under categorical in that sort of top left corner is the types, unique symbols. Distinguish assets by category, store types, or clustering. Do you need a chart? So you can do a dynamic pie chart cluster showing the category proportions at scale, or you can do different size circles or different ways to visualize that data. And then on the right side, sort of numeric and ratio data, compare. So you can do bivariate maps where you compare the ratios of like sort of year 1 versus year 2 sales growth. And then heat maps are dot density, so that kernel weighted surfaces showing concentrations of numerical values. Now, again, we talked about heat maps are one of those types of data visualizations that can come from both vector data or raster data. In this case, we're doing vector data, where what you're looking at here would be a representation of points. Where do the points concentrate to create a dot density map? And spatial medallion architecture is similar to any medallion architecture you're going to have working in Fabric. So it just requires preparation. So your bronze is your raw, sort of the standard. So you want to standardize your coordinates to typically to WGS 84. And then your silver layer, you're going to enrich that data. So perform geocoding, execute spatial joins, filter anomalies, null island. And then gold is your business ready. So surface aggregated spatial features and layers for Power BI directly. And so with that, so your bronze is that ingestion, that silver layer is transformation, and the gold layer becomes business aggregation. So you've got meta-driven, so starting with the bronze, you've got meta-driven pipelines, pull raw geographic features into ArcGIS, REST endpoints, or Python APIs, and paginates, dynamic offsets, lands raw JSON binary geometrics into Delta tables. And at the silver, you've got Spark notebooks, run GeoAnalytics and structural transformations. Multi-part geometries are resolved, code values, domains are decoded, and coordinate reference systems normalized, applied across all layers. And then your spatial dimension, for the business, your spatial dimension tables joined with operational business facts, hex binned aggregates written to one lake for downstream ArcGIS maps consumptions, kind of an example. But just, yeah, when I was in graduate school, I was often told this is the cleanest data you'll ever see because when we would do an assignment, they would often give us that gold layer of data that we got to work with. And then when I did my first internship with the US Geological Survey, that's where I started working with a lot of satellite imagery from Landsat and just other data sets that we were kind of directed to, but it was all in the bronze layer. It was all very raw data, and there was a lot of cleaning that I had to do. And I was like, oh, this is what it looks like in the wilds. And I was really happy for that internship because I got to spend a year kind of wrestling and learning the limitations of the storage capacity on my computer. That's one of the limitations and something you really want to be thinking about is and this is one of the reasons where that storage, and whether it's cloud storage or whether it's Microsoft Fabric, some of these data sets get quite large quite quickly. So you want to be very clear about what the limitations of your own compute is. Okay, so now we've got location AI, better decisions, AI models trained without location context or missing dimension. Spatial features are among the most powerful signals in predictive analytics. So what can they do? You can do wildfire risk prediction. So the burn, you can kind of analyze the burn severity, topography, weather. So you get pre-fire risk scoring by parcel. Site selection. So if you're a business, kind of saying, where should we do business? You can look at the demographic context, competitor proximity, travel time. So it can look at optimal locations, or also, relative to your other existing locations. Security threat detection. So you can look for IP geolocation, VPN clusters, anomalous login origins, attack mapping. They also, obviously, any kind of security with events and things like that. They want to see it. They want to see the map. They want to see the space. Route optimization, real-time traffic, road network, delivery windows. So how do you create last mile efficiency? Asset risk scoring. So your asset location, flood or seismic zones, climate projections, what is your exposure index? And then healthcare access gaps. So population density, facility distance, underserved zones can create an equity analysis. So there's just so many applications to this. So it's great for you to think about the domains that you work in and think through kind of how can you apply this. So now we'll do the deep dive into the ArcGIS for Microsoft Fabric. So you've got 3 products, 1 lake, no new tech stack, because you can do all of this now inside of Fabric. And this is in public preview, so meaning it's free. So you can jump right in and try it. And this is going to be your no code, low code solution. And so this is native mapping and visualization workload. Again, no code required, although I think I say no code, low code, but it's kind of positioned as kind of a no code entry point. Where it lives is your Fabric workload hub. Add it to your tenant like any other Fabric workload. There's no install, no external license during the preview needed. Living Atlas we talked about is an overlay of curated ArcGIS online layers. So you can get flood zones, demographics, wildfire risk, real-time weather directly on your data. And again, they also have all of the polygons for you to attach your data to. So you can do those kind of joins. What it does is it creates interactive web maps from Lakehouse data, supports heat map, aggregation points, comparison maps, and smart mapping. Output, it publishes a Fabric web map artifact back to your workspace. So it's shareable, embeddable, and governed like any Fabric item. So think of it as Power BI for location, visual, interactive, and publishable inside of Fabric. So yeah, location intelligence natively within the Fabric workspace. So frictionless onboarding, launched directly from the plus new item menu. The map behaves identically to other Fabric artifacts. Direct Lakehouse integration reads process data tables straight from OneLake. Smart Mapping AI automatically detects geospatial attributes and suggests cartographic styles based on the nature of your data. And scalable performance renders hundreds and thousands of pre-processed data points seamlessly in the browser. So ArcGIS maps for Fabric. You've got a native mapping workload accessible directly from the Fabric workload hub. This is all brand new. So that's why I'm so excited about it and so excited that you're here to share this, to sort of get out in front of it. And I just want you to know that I am here as your guide with a master's degree in GIS and someone who loves Fabric and has been a Microsoft student ambassador for the last 2.5 years. And as I'm graduating now as a co-lead on a user group for location intelligence and security. So totally excited to be your guide and support system, as you integrate this into your own workflows. So start with your workload hub and then connect that to OneLake. And then you can do that contextual enrichment. So overlay the ArcGIS Online context and Living Atlas and publish it. So share interactive Fabric web map artifacts. And then the styles that are available are heat maps. So you can visualize directly density of operational signals and concentrations, aggregated points, cluster millions of data points into readable spatial bins. Comparison maps evaluate multiple geographic variables side by side. And smart mapping is AI-guided suggestions based on your data type and questions. And so that's actually also what's happening in the GIS space is GeoAI. So AI is coming in and transforming how we do our own spatial analysis within ArcGIS Pro. And there's two types of it. One is you can ask questions. So they have their own sort of chat bot to say, what do I do next? Or how do I do this process? And that's also a great tool is using your AI to ask questions as you're deploying this. So I can be a resource, but so can your LLMs as you're looking to sort of answer questions of, hey, wait, how do I do this? Plus, Esri publishes tons and tons of documentation for all of this. So lots of resources to get started with this. But then also, and for like deep learning, machine learning, there's so many ways that it can take data and process it. That's actually one of the things that I do a lot of work with, and I have a GeoAI course that I developed and trainings that I do based on my year-long internship I had with the U.S. Geological Survey, where I sort of applying a deep learning model to multi-year recovery of a couple of different wildfires and seeing how that are in the same climate zone and how they compare with different years. So one's a 20-year fire and one's a 7-year fire in terms of how long ago it happened and how that how they track each other in terms of recovery, and you can sort of then infer kind of where the climate was and and then compare that to real climate data, and then do predictive analysis of where do we think this will go next. So there's kind of just fun things you can do when you bring AI into all of this. But going back to the data, so enriching your data with the Living Atlas. So your internal business data is already half the story. So you have One Lake House, so customer locations, transactions, asset registries, operational event log, incident dispatch records, and IoT sensor readings. And then you can add that to the ArcGIS Living Atlas of the world. So environmental, you've got wildfire, flood zones, climate, elevation. Demographic, population density, income levels, age distribution, infrastructure, roads, utilities, critical facilities, boundaries, lifestyle, you've got foot traffic, retail activities, mobility patterns, real-time weather, emergency alerts, live IoT streams. So all sorts of ways that your internal data tells the what, and you can now add sort of more, Living Atlas can tell you the why and the where it matters. And so using this sort of unified spatial lakehouse, no new tech stack required, multi-format interoperability in OneLake. So native reads, ArcGIS feature services, shapefiles, and shapefiles are kind of not the optimal, but I would say it's standard in GIS in terms of how location files are packaged. So you got your file, geodatabases, GeoJSON, ORC, and vector tiles. You've got GeoParquet integration, so explicitly spatial Apache Parquet formats, read directly without format conversion, and Delta Lake serialization, since Delta tables do not natively support spatial types. GeoAnalytics decodes JSON strings and WKT, WKB formats into recognized spatial geometries directly via PySpark and Scala. So that brings us, I'm going to just take a quick check in with everybody before we move to our next section. So hope everybody is doing well. Any other questions or anything that I can address before we move on to our next session? I check in with our mods. How's the chat going?
Chat's pretty clean.
All right. Well, I appreciate that. And yeah, so okay. So any if you have questions, let me know. I think part of what I'm wanting to do is, one, give you some language and some thoughts about spatial thinking and just the opportunity here. But I'm really excited to show you what's possible so that you can begin this journey and start to sort of integrate this into your thinking, into your workflows, into something that you're willing, you're wanting to take a closer look at and see what's there. Introduce it, not only to your own work, but to that of your colleagues and your teams, and see that there's quite a bit there. Oh, one more question for you guys. Where's everybody joining from? I see a lot of India in the chat. Where else? So, and I know we have our mods. We've got India represented, Africa represented. I'm here in the United States. So it's fun to sort of see everybody joining us. I love having these sort of very global stages. Okay, with that, I know we have a 90-minute session, so we've got half an hour to sort of wrap us out here. Let us continue with GeoAnalytics. Now, this offers 180 spatial functions, OneLake native, and it's been generally available since November of 2025. So the ArcGIS GeoAnalytics for Microsoft Fabric, this is a Spark native spatial computation library, 180 plus functions running inside your Fabric notebooks. Now there is a version of this that I have seen that I think the license starts about $1,000 a month. Could be more, maybe a little, but this is definitely like enterprise grade on some of this. But again, with a lot of this stuff, you don't necessarily need to start at enterprise. Your team will build up to that level of compute and that level of data storage and integrations when you're ready for it. So with all of this stuff, there's always kind of the free version of it, the modest subscription version of it, and then the we need to scale up version of it. So do not, when you look at all this stuff, if you see a price point that's a little intimidating, know that that's not where you need to start. There are other ways to kind of get what you need to get going, and then you can always scale up to what's needed. So here we are with the ArcGIS GeoAnalytics. It's where does it live? It's in Fabric Data Engineering and Data Science notebooks. It runs a Spark library, and import it like a Python package. The 3 core modules are the ST functions, which are geometry and relationships, the TRK functions, time sequencing tracking, tools, multi-step spatio-temporal algorithms. And we talked about spatial-temporal is that time over space, like what's changing, how things move and change over time. And what it does, it executes spatial operations at enterprise scale. So hotspot detection, spatial joins, buffer analysis, tracking, coordinate system transformations, and scale. So 59,000 pipeline road intersections analyzed in under 2 minutes, can be distributed across Spark Compute. And again, that's the generally available since November of 2025. So GeoAnalytics stacking reality over your OneLake data. So ArcGIS GeoAnalytics runs natively in Spark notebooks, so no separate install. You can do that hotspot and cluster analysis, identifying statistically significant spatial clusters, cold spots, an outlier in your data, spatial joins and enrichment, overlay data sets, pipelines versus roads, assets versus risk zones in under 2 minutes at enterprise scale, track and movement analysis, detect incidents from GPS data, calculate motion statistics, understand location change over time, and pattern and relationship mining, find what standard reports miss, proximity, containment, adjacency, and corridor analysis. And ArcGIS GeoAnalytics, Spark Native Compute, you've got 180 spatial functions across distributed clusters directly in Fabric Data Engineering. And your core modules are going to be geoanalytics_fabric.sql.functions. And that's it. ST is spatial relationships, geometry creation, and distance calculations. You've got geoanalytics_fabric.tracks.functions. That's the TRK. That's time sequencing tracking, duration, and speed. And you've got geoanalytics_fabric.tools. That's multi-step spatial temporal algorithms for clustering and summarization. And all of this code is available in various ways. And if you don't have all of it, your favorite LLM can definitely help. But Esri has extensive documentation to get you started. And a lot of times I will find that if I don't have a feature enabled that's in their sample code, I can just rewrite that code to get it to work with whatever I'm working with. For example, and we'll get into that next, if we're going to do a demo. I have done this demo with the free version, and then that free version became generally available and was no longer free. So I went back and I was able to rewrite it in a way that I could still run the demo without actually having that tool enabled. And that, I mean, it's a very, very basic data set we're going to look at, but the idea is that you don't have to have the full kind of enterprise grade subscription to actually run the demo that we're about to do. But and I have a sample notebook I can share in our post event follow up, because I do think it's, you can run it and then you can make your own map. So we'll do that next. Right now I'm going to run us through just kind of the idea, understanding the boundary where business intelligence ends and GIS begins. So the goal is collaboration, not replacement. So this is not going to phase out the GIS teams. It's not going to replace the GIS teams. GIS professionals, there's a lot that they do that is unique to their skill set. And you'll find that most GIS professionals have university certificates, have master's degrees. There's a lot that goes into it, or they have just years on the job. And they have probably at some point, or maybe more than once, cried in learning it. It is not easy. So this is not meant to replace. If anything, we'd like you to have some respect for your GIS colleagues and all that they do. But this gives you an opportunity to now start speaking the same language and start applying the basics of this into your work as data scientists, because that column with location information exists in your data and you should not ignore it. You should now have the opportunity to fully visualize it and exploit it and learn from it and add more layers that enrich that data and can tell you more. So that's what I'm excited to do, is just inspire you to be data professionals who embrace location, who embrace maps, who embrace spatial thinking. And so BI tools handle the spatial joins, the region aggregation, the proximity checks, the basic enrichment. So there's a lot you can do in Fabric, in Power BI, in Excel. But don't worry that you aren't going to do everything, and that there's especially within enterprise, there's points where things are kind of handed off to the GIS team. So the goal is to get everybody to work collaboratively, not competitively. And again, so what do you have? You've got in GeoAnalytics, you've got 180 plus spatial SQL functions and analysis tools. Things can be done in less than 2 minutes. You can analyze 59,000 pipeline and road intersections, analyze to enterprise scales, and it's in general availability. You've got your unified spatial lakehouse. Microsoft Fabric does not force a silo. ArcGIS integrates alongside open source geospatial formats directly in one lake. We talked about Esri being proprietary. You've got the one lake repository and open source and custom libraries that you can add to your analysis. So you've got one lake, leads to Fabric runtime, Spark and GeoAnalytics, to Direct Lake, into ArcGIS maps for Fabric and Power BI. So now you've kind of got that whole sort of foundation. And so here's a demo. And we talked a bit about the sort of analytical divide between traditional BI and spatial BI. So, role of location, visual output, analytical joins, contextual reality. So the traditional BI is, a label used for filtering or grouping. The visual output is a flat chart, a grid, a static shape map. The analytical joins is exact strings matching or foreign keys. And contextual reality is limited to internal CRM ERP tables. So now that we're bringing spatial business intelligence into Fabric, you've got, for your role of location, it's a mathematical signal for proximity, routing, or spatial indexing. Visual output, you've got dynamic multi-scale web maps and 3D topographic renders. And then your analytical joins, you've got spatial intersections. So is it contained? Is it overlap? Is it within? And then contextual reality enriched by the ArcGIS Living Atlas and environmental data. So where location intelligence pays off: security, risk and insurance, public sector, logistics and supply, location-aware AI, and operations. And so location is your most powerful signal. So location is an attribute. So you've got a zip code. You can filter in a where clause. You can group by region or territory. You can display as a label. And it's never analyzed spatially. So that's where sort of most data platforms stop. But now when you add location, you can have that proximity reveals risk. How close is this asset to a flood zone? Clusters reveal demand. Where do customers actually concentrate? Routes reveal efficiency. Which paths minimize exposure and or are most efficient? And then context reveals meaning. One coordinate unlocks demographics and behavior. So now we're in just a visualization of the Fabric tenant. And so here you are, you've got your workspace, your general. If you work in Fabric all the time, this is going to be very familiar to you. If you're seeing this for the first time, when you sign up for Fabric, and you can get a 2-week free trial. You can get a 2-month free trial. You can get in and explore and kind of create your own projects and your own notebooks. And you can see learn more about Fabric right in Fabric. There's free hands-on workshops. And of course, we're part of Data Days, so you're just going to get, this is one of hundreds of events that are happening, and they're excited to get everybody to be able to get certifications in all of this. So there's so much that's available to you now through this Data Days event. But you can see there's lots of ways you can explore and kind of create your data and manage your data. And then here's a notebook that we've created. So this was kind of the import GeoAnalytics Fabric from from GeoAnalytics_Fabric, and all of this code, I'll show you where you can get it. And then running, each of these tables, running each of these sort of snippets of code yields kind of the information. So we were able to use that to create this information about what county, what state, what's the population per square mile, and then what is the coordinates, what's the actual shape of that polygon. And here we've got the name, the population, the square mileage. So we're kind of continuing to run the code and sort of now we've kind of got it based on the counties. And then we're able to do within the United States and the state of Georgia, you've got the counties by population. And so you can see sort of where everybody lives, which is basically in and around Atlanta. Other than that, it's a very rural state. And you can see kind of where those highest concentrations of people live. Now, with spatial analysis, there's different ways to look at that data, organize that data, where you kind of break your data, how you want to visualize it. You may, and are you doing it by number of people? Are you doing it number of people per square mile? So this is where visualizations matter and can definitely change based on what exactly it is that you're analyzing. And the QR code to get there is on screen there, and it's also a link we can drop in the chat, or it'll also be part of your post-event resources. So you can go in there, and I also have and will include a notebook that you can actually run that whole sequence with and get the same result without ever enabling any of the official tools. And so then want to just do a check-in before we go into our last and final session before we wrap up of what happens next. Where do you take this in terms of resources, communities, certifications, and your next steps? So just going to do a round where I check in with our mods, see if there's any other questions to ask, and just how things are going. Lee.
Hi. Everything's kind of okay. No questions, no major questions. Just confirmations and asking about latest learn module released to the topic. That's, oh my god, I can't say their name. Gobenda Palm 68 just asked, is there any Microsoft Learn module related to the topic? And can you share a little, Ginger Bean and /V asks, can you share a little bit about data extraction collection for GeoAnalytics?
Yes, sounds good. Excellent. Yeah, I actually would like to do my own deeper dive into Microsoft Learn. I think a lot of these exist right now in Esri, and Esri has a lot of free learning opportunities and tools. And if you're really new to spatial data science, they have these wonderful free MOOCs, which are massive open online courses. So they're a combination of async and async, and so they'll happen over kind of a 6-week period. And in that case, I mean, this is if you really want to do a little bit of a deeper dive, you'll get access to the Esri software. So outside of Fabric, just using the actual Esri platform. But it's a really great course. And even if you don't finish the course, even if you're like, I'm just going to check out week 1, it's kind of worth it. There's some really good information, and it really will just kind of take you further in spatial thinking. And they have different concepts, and they're all free, and they're offered throughout the year. And I do post kind of those schedules. I'll have a whole bunch of new ones kind of coming up and available in the fall. So I do highly recommend looking into the Esri learning. I think for spatial, you're going to get more. Now, as far as using Fabric and getting more out of Fabric, there is definitely quite a bit in Microsoft Learn. And I will look and create, actually, we've been invited as student ambassadors to kind of create learning paths we can share. I haven't created mine yet, so that's a really great question. And I welcome the opportunity to do that, to kind of give you more opportunities to sort of say, here's where you can kind of go to expand your spatial thinking. I'm not sure if you guys can hear it or I can't. I literally have landscapers like outside my window, so I do apologize for that. Okay, so let's get into licensing ecosystem
We have a few
limitations.
questions.
Oh, we take them. Yes.
Okay, I have a few questions from Krishna Kant. I hope I'm saying it right, Adeshvi. He's asking you what are the best practices for optimizing map visuals when working with large geospatial data sets?
Well, I think I'm always going to think of it in terms of being um, map reader, map leader, and map maker in that order. So think of it first of all, if you were the map reader, are you understanding what the data source is, what the data science question is, and what the spatial question is? And so as you go about being more aware of maps, and as you do a deeper dive into these tools and these resources, you start to read maps and you start to see, does this make sense? Is this doing what it needs to do as far as they literally have a chainsaw going on outside my window? Um, anyway, sorry about that. Okay, so I live in an HOA that I cannot control this. Okay, so so hopefully you can hear me okay. The and I can get my focus back. All right. So when it comes to map making, just think of it. Look at anything from the perspective of your audience. Do they get what you are trying to say, or can it be communicated and expressed more clearly? There is a term that women sometimes use, and I say this with love to all my male friends and audience, called mansplaining, where sometimes it's the idea that men will have over-explain something to a woman, and we're like, we get it, we're okay. There's a term called map-splaining. You should not need to explain your map, so do not map-splain. Your map should speak for itself. Your data surrounding your map, your legends, everything should be as clear and clean and understandable to your audience without you having to look over their shoulder and explain to them what you're trying to communicate. So when you sort of say, how do I make this as effective as it can be? Ask your audience, what they're getting from it, which goes to the next point, which is map leader. Because the point of a map, if you're putting all this time and energy into creating a data map, is for a leader to make a decision, for a team to discuss it and say, okay, now that we see it, and we can see it visually, and we can see it on a map, what are we to decide? What kind of decisions are we going to make? And how effective is the map you created able to help those leaders or that management team make decisions? And then the map maker part of it is where you get into the details of actually creating and making the map. And so I would think of it in those perspectives of being a map reader and then looking at a map from your reader's perspective, and then being a map leader and looking at the map from your leader's perspective, and then being the map maker is where you get into all the details of how you actually made your map. Does that answer that question?
I hope it does. Well, it has to. It's very clear indeed. I've also have another questions from him, but they're Fabric related. He's asking, can you share one example how GeoAnalytics in Fabric have been applied to solve real-world problems? And how do you see AI enhancing location intelligence in Fabric over the next few years? What skills should data professionals focus to get started with maps and GeoAnalytics in Fabric? And the last one is, how does Microsoft Fabric integrates spatial data with traditional business intelligence workflows? That's a mouthful, but should I repeat?
I think we just need to break them down one at a time. So just yes, throw them at me one at a time.
Okay, let's start. Can you share one example how geoanalytics in Fabric has been applied to solve real-world problems? That's the first question he gave me.
Okay, and I'm going to say that it's a two-part. I'm going to break that into it being a two-part question because I think that the very first question is how does GIS or how does spatial data science solve real-world questions? I think the second one is in Fabric. Fabric is the tool. Fabric is where we store data, where we process data, where we can now enhance that data through access to Esri's tools. But I think to answer the question of how has spatial data helped solve real world problems, Esri is an encyclopedia of that. I will be attending for my fourth year the Esri User Conference, where we get to spend 5 days plus pre-conference stuff, so 7 days, um, looking at case study after case study after case study of how spatial data science solves real world problems. It solves it for business. Any question you want to ask about performance or future or risks, especially climate risks. Are any of our facilities, any of our data, any of our employees at risk for any kind of environmental um, flood, fire, hurricane, wind damage, tornado? Do we have gaps in food availability, food distribution? I'm speaking to the United States, but I'm sure this applies to the world. There's things called food deserts. You can look at people and say, do they have access to grocery stores or farmers markets or locally grown produce? Like, are people getting what they need in terms of medical health and accessibility? You can do it for route planning. If you have a delivery service or any kind of sales agents on the road, are they optimizing their time and their routes? You can do it for any kind of planning or development. Retail stores, everything from foot traffic to competitors to weather. What are the drivers behind the things that are happening in your business, and which ones can, again, back to the decision making part. How can we use this information to make better decisions? So I really think the question is, what area of the world does it not impact? And I think the reality is there's every industry and every uh, business question or environmental question or policy question or anything when you're dealing with, again, people. I came into this from a background in urban planning, and it was when I realized like how the data science applies to every aspect of how we plan and how we manage our cities and how we manage our transportation and how we manage our energy. If you think about just from a basic urban planning problem, the issue is that we as people require energy. We need energy to move our vehicles. We need energy to keep us warm. We need energy, but energy is expensive to produce. Energy is dirty to produce. And so that's the biggest conflict, of just being human. And so once you have that kind of tension between a clean environment versus an energy environment, same thing, like we want clean environments and healthy forests and uh, you know, care for animals and all of the environmental factors, but we also need jobs and economy. Jobs and economy, like I said, go back to that. It's not always the cleanest business to do business, but we as people need energy. And so those are, so whenever you have a tension, spatial data mapping can help you understand what those tensions are and in which ones you will favor and why at any given sort of point of decision making. So I hope that helps. And so that was a bit of a longer answer for that.
It did. You did answer it. Thanks. Uh, Here's the second question. How do you see AI enhancing location intelligence in Fabric over the next few years?
I think that AI is just so good at pattern recognition, and AI just it can help in a lot. Well, one, it can help just in our ability to do things. Like I refer to myself as a baby developer. I love being a developer. I love to code. But at the same time, I think I love it more because I have more confidence. I know Stack Overflow exists and has been there, as tried and true for many, many years for all developers to bring their questions and kind of look for what is that answer to writing code. But now you can go to your favorite LLM and say, hey, how do I write this piece of code? So just having more confidence in creating anything that you're going to create and just doing everything we're talking about doing here, your LLM is perfect for being able to go ahead and answer the questions and help you create that notebook, or if something's not working, it will help you troubleshoot it. But then when you're dealing with large amounts of data and you have questions about that data, AI is going to be able to pattern recognize much, much faster than it can be done manually, especially if you're wanting to get into sort of the deep learning and machine learning around your data. So you can, again, some of those patterns become much more obvious, and then that leads into predictive analysis. So now you can say, okay, we've seen historically under these different conditions what has happened and where is it going to go next. So when I say conditions, I'll use an example. When you're looking at wildfire recovery, there's 3 conditions. It's either a wet year, a normal year, or a dry year. And you can see very, very specifically in how the data has historically played out. When it's wet, it recovers more. When it's normal, it's moderate. And when it's dry, it really drops. You can see that the recovery just crashes. And so then you can actually play it out saying, okay, if the future is wet, how will it go? If the future is normal, how will it go? If the future is dry, how will it go? And you can then, mathematically see sort of in graphs what that's going to look like. So predictive analysis is going to be a big part of it, of how GeoAI, I think, will sort of be able to take all of this further.
Okay. So the next question is, what skills should data professional focus on to get started with maps and geoanalytics in Fabric?
I think one of the things is just not being afraid of it is my biggest thing. I think that in the way that I see that we are brought up in our different silos, there is this idea that, oh, that's someone else. I don't do that. Someone else does that. And I want to challenge that and say, no, you can do it too. and to just start by learning the language. So we've all seen them, but we may not have had language for what is that type of map that has polygons on it, that has different concentrations of color. That's a choropleth map. We've looked at today heat maps. We've looked at today, and then there's topographic maps. There's thematic maps. So starting to learn the language of maps is a great place to start. And that's where some of the Esri tools and documentations and some of their MOOCs are really not designed to sort of, again, make you into sort of a full-fledged GIS professional, but they are designed to help you get familiar with the terminology so it's not so foreign to you, and that you can start to equate the terminology with like, oh, that's the same thing as I already do as a data scientist or BI professional. It just has a different name for it. So I think that's one of the parts of it, is that to not be afraid of it. That's why, to me, if you've never run a notebook that's created a data map, I have that notebook for you. You can run it, and you don't even have to run it in Fabric. You can run it in Colab or VS Code, and then you've made your first data map. So I think that the big thing for me is just don't be afraid of it, and then showing up here, being part of this conversation, is a fantastic first step. Building your community of people that you can go and ask questions to, and finding your tribe of people who are interested in that. That's why we created our user group, so that we can all kind of approach this together and answer these questions together and create community together, so that we're finding the application, finding the tools, and working through it, and that you're not sort of stuck with any blockers.
Wonderful. Okay, so how does Microsoft integrate spatial data with traditional business intelligence workflows?
Well, they're doing it with this integration with Esri. I think that's the easiest answer, is how they're doing it. They're doing it with Esri. And they've outsourced a lot of this here, again, technical weight to what our Esri already has. So let's wrap this up, because I know we're at time, and I want to make sure I'm respectful of every time, and we can always stay a little bit longer. But I just want to let's wrap it up, and then I can happily take any additional questions. So licensing, again, there's free. You can start this in Excel. as ArcGIS Maps, standard Power BI. You can just run independent notebooks. You can enable the GeoAnalytics at scale and enterprise. And again, they have full production workloads, but it does require the commercial licensing. So start with the data that you have. So my number one thing would be look at data sets that you're already working with and see if there is any kind of location data in that data set. Is there a longitude and latitude? Is there a zip code or a postal code? Is there a street address? Is there a store ID or an asset ID that you can join to geometry? Is there a county or state or administrative boundary? So number one is see that the data that you have, where is the location information that you might have ignored before that you can now start to integrate into your analysis and your visualizations. So you're going to want to get hands-on. So again, ArcGIS Maps now is in public preview, so you can definitely for free, if you have your Fabric account, kind of jump in and give it a try. You can get certified. So DB600, DB700, DB800, they're offering that certification all summer long. And then get connected, join the Esri. They have an early adopter community. We have a user group, so we'll continue to bring in guest speakers and host events and do Q&As and other things that can help sort of expedite your journey. And then again, so you're going to start with look for spatial data in the data that you already have and the data science and analysis issues that you're already addressing. Use the tools where you already work: Excel, Power BI, Fabric. Again, is there a spatial layer? Python, you can do Copilot, Power Query in Excel. If you don't already know Power BI and Fabric, definitely go deeper there. And then you can work through GeoAnalytics learning paths. I'm going to pull out and find in our post-event resources some of the very specific Microsoft Learn modules and some of Esri's tools. And then there's a lot of other resources I can also point you to. But a big part of it is start learning the language so that it's comfortable for you. So seek, join, engage, start mapping. And then we have a series of events. We're going to be having a Global Fabric Day, get to know Esri. We'll do even a deeper dive into Esri, data and AI security and governance in Fabric, Fabric IQ for data professionals, Win the Seams, kind of putting together data and security, and then a dedicated KQL for data and security professionals. And then some of the key resources, again, I'll share these in our post-event resources, but definitely dump into like the Data Days full schedule. And there's just great stuff. So we're at the top of the hour. And so build your foundations, get your certifications, and then, engage, sort of your spatial mastery. You will get there. It's all very learnable. And the more hands-on you can get, the more fun it will be. So the dimension missing from traditional Power BI. So we have the what, we have the where, and now we have the what, we have the when, and now we're just adding the where. And so we found the missing dimension that will make you all stronger. And just again, this is all sort of at the cutting edge of where this is going next. And I'm so excited for it, and I'm here for it because it's taking my two favorite things, which are being a GIS professional and being a data science professional and being a security professional and loving AI and seeing, like I said, where I feel like they've been siloed. Now I think there's just such an exciting opportunity to bring this all together. So with that, I'm going to formally close because we're at the top of the hour. So anybody needs to jump, you're free. Thank you for joining us today. Loved having you here. Look forward to having you join us for more of our Summer Data Day events. Look out for some of the post-event resources. I want to thank all of our moderators, and I will hang out for a few moments and take a few more questions. And I want to hear from our moderators as well. What were your biggest takeaways from today? Because this is all new for you. I know you guys are data science professionals and students in data science, data analytics, BI. But what were some of your biggest takeaways from today? Lee, I'll start with you.
I've actually learned a lot that we're able to integrate this and use it in real life practice as we can integrate it. And there's a lot of frameworks and libraries to use to help us integrate it into our own platforms. Okay.
I love it. Great. Krishika?
Yeah. So my biggest takeaways will be like the maps and geoanalytics are now the first class citizens in Microsoft Fabric, enabling the richer insights beyond the traditional charts and combining the geography with business metrics, which also helps uncovering the regional drivers and the market opportunities. And the Fabric's unified platform, which also handles the large geospatial datasets efficiently and making the advanced analytics accessible to both technical and business users. Yeah, thank you.
Fantastic. And Nikita?
Um, it was a great overview for me because I'm really new to this space, and it really helped me set the context around how the geospatial analytics actually works and how it is like actually used in Microsoft. I was not really sure about that. Obviously, some concepts were like super new to me, but the session really like made it easier to understand the overall workflow and how everything like comes together. I mean, I am looking forward for like a lot of more step by step demos in the future to like actually get started into like the workbooks and like you mentioned the collab labs, right? So I'm really looking forward to that. Also have one silly question. It might be really silly, but it's about like the medallion architecture you mentioned at the start of the program. So that was a bronze layer, right? So how does the metadata driven, like the whole thing runs on metadata, right? From the ingested geolocations. So obviously with time, the metadata kind of changes, like the schema drifts from what you initially began with. So is there anything like that automates this like process to like adjust the whole architecture for this metadata changes, or is it something like we have to do it on our own?
I guess it really metadata is so important, and it really is key to understanding how useful your data is, where it's sourced from, how reliable it's going to be. So I mean, we use a thing called Arc. So there's ArcGIS Living Atlas, which is the gold. Like, I mean, it is the platinum standard. It is the gold. It is the best standard that you're going to have for uh, data that comes with the full metadata. But with a lot of other data that we use, like for example, we have access to sort of ArcGIS Online, which is just where other people post data that you can use. But I will tell you that the metadata there is greatly lacking. So as far as I think you were asking kind of how AI can help with that, sometimes I just think about like how helpful AI is in terms of like I can just put a lot of information in and I can ask the AI to help me organize it, just answer questions about it, clean it, help me prepare it for documentation. Uh, and inside of Fabric, how does it help in terms of metadata? That's a wonderful question. I actually think we could do a whole session dedicated to metadata because I think metadata is one of the often ignored and perhaps arguably the most important piece that goes with uh, any kind of data, but especially spatial data, because you do need to understand where it came from. I mentioned briefly VGI, volunteered great geographic information. On one level, like that can be so valuable because people at a street level all around the world are contributing data, but it's patchy because they're having to do it as a volunteer out of their own motivation. So it's not so much when you look at VGI what's there. You have to be very conscious about what's missing. Where are the gaps? What are they not reporting? And the same. And so you have to, if the data is collected from sensors, it was like, well, where were the sensors and why are they there? Where were the sensors not? What's missing? And that's actually another sort of spatial data science concept. Well, you get that concept in statistics anyways, but interpolation is where you only have a handful of points or data, and then you have to sort of guess based on what you have, can it figure out what's not there and fill in the gaps. So for topography, for example, you've got hills and valleys. You only have a few points, but if you give it enough points, we did another one which was also sort of bathymetry, which is depth of the ocean. And so you had certain depth points, and then can you guess and create a map of what it's going to look like without that other information. So yeah, metadata is huge, but like I said, a lot of data comes with what's there, but then you have to take that extra step to sort of understand, well, what's not there. Does that help?
Yes. I mean, if you're going to do the session, I'm already in that. Also, yes, I kind of understood what you meant.
Yeah. Excellent. Well, we have a lot to cover. We covered a lot. There's so much more. Excited again. I thank everybody for being here and your interest in this topic. There's so much more, and I just wanted to sort of kick it off with my passion and expertise. But the whole goal of Data Days is to share the stage and to bring in other people's expertise. And I applaud our moderators for their hard work and dedication today, and just keeping the chat lively and going. And I thank you all for everything. And if you have come to this YouTube without having sort of registered for the event, I do encourage you to go into the description and register for the event. If you like this, give it a like. That helps the algorithm. But also wanted to just say that the Luma is there for sort of post-event resources and other ways we can communicate with you. So do recommend everybody to sort of register for the event through Luma. And with that, I'm going to go ahead and wrap out our event for the day and just thank everybody so much for being here.